Trip problem. Half of the screen is not covered. Get started. So basics பார்த்தோம்ல அதுல ஏதாவது doubts இருக்கா? Any doubts from there? No, right? So now we are going to get into the mathematical detail. Okay, so get into the mathematical detail. We get started. The basics. I'm going to explain some important terms. In which the first one is about how do we represent a way mathematics. Write down the indicators. equation of a wave. So this wave is also called as a plane progressive wave. So what is it called as? It is also called as a plane progressive. Okay. So the equation for this is y is equal to a times sine of kx minus omega, right? So this is the equation of a plane progressive wave where this y represents the displacement of particles. A represents the amplitude of the particle that is oscillating, right? K stands for a number called as angular wave number. Omega stands for angular frequency, right? So these are all the terms that are related to this particular plane progressive wave. Y is equal to a sine of kx minus omega t. If you observe, unlike particle that is there in simple harmonic motion, here the particle that is actually the displacement of the particle that is present on a wave is given as a function of x comma t, meaning though the displacement of particle is existing along y direction, right? So it says that the particle is vibrating along x direction, but the energy is getting transmitted along the x direction. And here the negative sign indicates, okay, I'm not showing you the derivation of this. The negative sign indicates that the wave is traveling in the positive x direction. Okay, so what does the negative sign indicate here? Negative sign indicates that the direction of propagation is in positive x direction. Okay. The reason being, that is how it is direct. So what they do is they take a particle and consider the relative displacement of the particle with some time and all those things. See, that is not a part of your syllabus. That is why I'm not explaining. It's based on time. So y is equal to a sine of kx minus omega t. Let me repeat it. Y is going to be the displacement of the particle which is oscillating. X is going to be the direction in which the energy is getting transmitted. Right? K is going to be called as the angular wave number. You know what is the wave number? What is the wave number? The number of waves per unit. If you talk about the number of waves per unit time, it becomes frequency. If you talk about the number of waves per unit length, it becomes a parameter called as wave number, which is basically 1 by lambda. Right? So wave number multiplied. Remember this concept. Whenever you have terms like this, wave number, which has a prefix of angular, frequency, which has a prefix of angular, you need to always multiply those values with 2 pi. So what I'm trying to tell you here is wave number is given as 2 pi, angular wave number is given as 2 pi times wave number, which is generally represented with u with a bar on top of. So nu bar, right? Or this can also be written as 2 pi divided by lambda. Similarly, what is the value of omega? Omega is equal to 2 pi by t, or it can also be written as 2 pi into, right? So I hope this is clear. So this is another important point to be noted, that y is a function of x comma t. So whatever you write in the bracket are termed as the variables, right? Y is a function of x comma t. And what is this? This whole expression is going to be the equation of a plane progressive wave. What is the meaning of this plane progressive wave? Progressive, the name itself is suggesting. Progressive means it's a traveling wave, right? So plane is added in as a prefix to it because you can actually draw a plane through that particular travel. Need not be. Whatever is the wave, you always represent it using the same. There is an expression for a plane progressive wave. That is what I told you in the previous class. I told you whether it is a transverse wave or a longitudinal wave, it is always represented using sine function. Okay, just because I wrote it in such a way that the particle is oscillating along right there, is transmitted along x wave is represented in this. Okay. That is how it is derived. I told you, the relative displacement concept will be taken during the derivation also we will get it. Okay. So as I mentioned, that part is on video. This is clear. I hope you made a note of it. The progressive wave may be transverse or longitudinal. For both, it will be the same. Basically, if I have to give you a definition of wave knowledge is progressive. Right. So whenever you have the transmission of energy taking place, you give a name to it called as a plane progressive. If a particular wave is able to travel in a medium with constant amplitude and without damping, you give a name to that kind of the wave as a plane progressive wave or a traveling wave. Okay. So when you talk about a wave, it can be longitudinal or transverse because there is only a mathematical condition. I'm repeating it again. Whether you talk about longitudinal or transverse, what is importantly happening? There is vibration of particle taking place. So if you recollect the concept from previous chapter, there is a concept called as projection of uniform circular motion onto a particle in SHM. See, if you ask me the same question, I'll say, is a particle actually moving in the sine wave format? No. It is actually moving in a circular format which is projected on a wall which appears to move in a linear motion. Then why did we write it as a function of sine? Because we are trying to represent it by taking the help of circular motion into consideration. In a similar way, whether it is a transverse wave or a longitudinal wave, as long as it is going to be progressive in nature, it's the equation. Right. Shall we proceed? So I'm going to touch y is a function of x comma t. Means the displacement of a particle will change as a function of x. Means x is also variable, time is also variable. If you write y is equal to a sin omega t, y will change only with time. But if you write it as y is equal to a sin of kx minus omega t, y will change with respect to displacement and time. Other meaning of function of the variables. Got it? Now the next question is relation between, see, you know this concept already, but I'm explaining. The relation between wavelength, frequency, speed. The speed means here I'm talking about the speed of the wave, not the particle. Okay. So what is the relation between? if I represent a wave as a function of sine, okay? So if I take it as a function of sine, which is y, let's say this t, for instance. Okay. Now, starting from here, starting from A to B, can I say this is one complete oscillation? So in one complete oscillation, you have a positive cycle and a negative cycle. So in one complete oscillation, what is the distance traveled by the particle? In one complete oscillation, distance traveled by the particle is what? Is lambda. Those who are online are able to hear.
Yes, sir.
Okay.
Yes, sir.
Okay. So in one complete oscillation, distance traveled by the particle is lambda. But what is the time taken by to complete one oscillation? So time taken is equal to capital T. Right. So time taken is capital T. So how do you define the speed of the wave? So speed of the wave, can I say it is the distance per unit time? So speed, if I represent it as v, what is the distance traveled by the particle? It is lambda, and the time taken by the particle is capital. So from this, what can I say? V is equal to lambda into. So the speed of the wave is equal to wavelength multiplied with frequency, or wavelength is equal to speed divided by frequency. Both are same. So you can also write it as or lambda is equal to v divided by l. I'm sure you already know this basic, but I'm just showing you the derivation of how it works. Right? I hope it's clear. Please begin. Let me. Yes. So next is another important topic. So now we saw what is the relation between wavelength frequency and the wave speed. Right? So Wave speed is also called as phase velocity. This is another term. Wave velocity is also called as phase velocity. Have that in your mind. Now, having this point in mind, we will take this equation into consideration. I'm going to start the text. Y is equal to a sine of kx minus omega. Right, this is the equation that we have now. I'm going to get into slightly mathematical details. So everybody knows differentiation. Right? So when you differentiate a sine function, what do we get? You get cos. Okay, but the challenge here is when you are trying to differentiate, you need a function to be, you need an expression, you need a variable to be a function of one variable. Y should be a function of either time or x. Right, but here it's a function of both the variables. So what I need to do is something called as a partial differentiation. Meaning, I will once differentiate this y with respect to time. When I differentiate this y with respect to time, x will be taken as a constant. Listen to this here. When I differentiate y with respect to time, x is treated like a constant. When I differentiate y with respect to x, time is taken as a constant. Okay, so we'll be finding two parameters. One is dy by dx, and the second is dy by dt. Let's see what it is. So if I find dy by dx, then what is going to be? It is going to be a, we will write this as a derivative. Derivative of sine is cos. So cos of, what you have is you write the angle as it is kx minus omega dot, listen to this here, into d by dt of this kx minus omega t. Sorry, d by dx. Correction. Into d by dx of this kx minus omega t. Am I right? So kx minus omega t. So what will we get? We will get a cos of kx minus omega t into derivative of kx minus omega t with respect to x. I told you when you're differentiating with respect to x, sin is taken as a constant. So derivative of kx will be k minus derivative of omega t will be 0. So you will get k here. Alright. So this is going to be k into cos of kx minus omega t, and this is going to be dy divided by dx. The first point we noted. Right. The next question is, if I do dy by dt, what am I going to get? If I do dy by dt, I'll get a times, tell me, a times cos of kx minus omega t into d by dt of kx minus omega t. So what is the answer for this? It will be a cos of kx minus omega t into derivative of kx minus omega t will be minus into minus omega. So this will be minus a omega into cos of kx minus omega t. Can I take this as equation 1? Now if you observe, I can do a mathematical manipulation between these. I can divide them, I can multiply them, do whatever it is in such a way. I don't want this cos function to exist between. So if I don't want cos function in 1 and 2, what am I supposed to do? I'll obviously divide both. When I do this, observe what I'm doing. So I'm doing dy by dt divided by dx by dt. So what is dy by dt? Dy by dt is minus a omega cos of kx minus omega t divided by, what is dx by dt? It is ak cos of kx minus omega. It is ak cos of kx minus omega t. So a and a are gone, cos kx minus omega t and cos kx minus omega t are gone. This will be minus omega divided by k. Right. So can I write dy by dx So I would dy by dx both sides. Okay. The correction here is this should be dy by dx. Or dy by dx. So dy divided by dx. So dy by dt divided by dy by dx will be in such a way that can I write dy by dx is equal to, and take dy by dx to the other side, omega by k to the left hand. So can I write it as minus k divided by omega into dy by dt? Right. Now I need to start giving names to these terms. So this dy by dx can I call as the slope? Right. So change in y coordinate with respect to the change in x coordinate mathematically is called as slope. So dy by dx is called as the slope of the wave is equal to minus k by omega is there. No, minus k by omega, I am operating it separately. Observe, k is basically 2 pi by lambda and omega is 2 pi by t, or can I write it as 2 pi into m? Can I write it as 2 pi into m? So 2 pi and 2 pi get cancelled. This will be equal to 1 by lambda times m. What is 1 by lambda times m? What is 1 by lambda times m? It is 1 divided by, just now we saw, it is called as the wave speed. Okay. So slope is equal to negative of 1 by speed of wave, or I can call it as wave velocity also, into what is dy by dt? Rate of change of displacement of the particle. It is called as particle velocity. So here what I am trying to say is slope of a wave at a particular point is going to be negative of the particle velocity divided by the speed of the wave. Okay. Here one point you need to be clear with this. Particle velocity and speed of wave, what is the other name I told you, it is called as phase velocity. Phase velocity. Particle velocity and phase velocity are not the same. So this is an important expression where if I try to rearrange and write, I can write the things. Speed of the particle, that is particle velocity is equal to, I take all these parameters to the left, will be equal to negative of slope of wave into wave velocity. So this is going to be another important expression that we need. Am I clear with this? Are you able to understand? Right? Now make a note of all this. Okay. Next week we come to the question. Next week we'll build some more basics. Beats சொல்லிட்டாங்க. Proper effective beat. சொல்லிட்டாங்க. The part of the derivation. And the next topic we are going to discuss is, right? So the next topic that we will discuss is speed of, right? Right on the next heading as speed of a transverse wave on a stretch string. So now our topic of discussion is speed of transverse wave on a stretch string. See, put it simple. You would have seen this musical instruments and everything, right? Suppose I take this to be the string. Right, if I take this to be the string, now I can produce sound from this, the first place, only if it has tension associated. Right. If, for example, if it is flat like this, if it is hanging like this, right, I'm going to pluck somewhere. If I'm going to pluck somewhere, nothing will happen. It's not going like proper. Whereas if I need a sharp stump, what I need to do is I need to create a tension in it. And if you start plucking it here, when you go closer, right, you can hear some sound. Right. So if that should happen, for you to calculate the speed of the transverse wave. So what is happening on a string, the wave that is actually getting created is a transverse wave. First point to be. So this tells us that all the musical instruments which are associated with the string are going to work on transverse wave. They are going to create a transverse wave and then. So what is the important condition for a string? First thing, it should have tension associated. Okay. Second thing is, the string will have a certain mass per unit length associated with it. I'm not talking about the mass of the string as a whole. I'm talking about mass per unit length because you can create a tension between any two lengths that you. Okay, that is why we don't take the mass into consideration, rather we take the mass per unit length into consideration. So the speed of the wave that is traveling depends on two parameters. What are they? One is the tension that you create in the string, and the second is the mass per unit length of that particular string. Okay. So speed of a wave on string is observed to be dependent on the first part, which is the tension in the string. The second part is mass per unit length of the string, which is U. Right? This mass per unit length is also called as linear mass density. So having these 2 points in mind, right? Having these 2 points in mind, what we will do is we will create a dimensional, we will try to derive the relation using dimensional analysis. Okay. P is observed to be directly proportional to the tension raised to the power A, mu raised to the power A. So P is equal to some A times T power A into mu power. So according to dimensional analysis, what could happen? The dimensional formula of T should be equal to K is the dimensional constant. The dimensional formula of T raised to the power A into mu raised to the power A. So what is going to be the dimensional formula of speed? It is going to be m0 L T minus 1 is equal to. What is going to be the dimensional formula of tension? Tension is basically force. Force is mass to acceleration. M L T minus 2 raised to the power A into mu is M L minus 1 raised to the power B. That's the mass per unit. So on the right hand side, if I combine, I'll write it as M power A plus B, right? M power A into M power B is M power A plus B. L power A into L power minus B is L power A minus B and T power minus B. Am I right? So comparing on both the sides, what will I get? I'll get A plus B is 0. A minus B is 1 and minus 2A is minus 1, which implies A is equal to half. If A is equal to half, right? If I substitute it here, then I get B is equal to minus half. So what I'm doing, A is equal to half, I'm substituting here, I'll get B is equal to minus half. So if I take this to be 1 and A is equal to half and B is equal to minus half, if I take it as 2, right? Then what will I get the value of B as? Okay, I'll take this as. So what will I get the value of B as? I'll get it as K into T power half into mu power minus half. So it will be K into of T divided by, and experimentally it was observed that the value of K is equal to 1. Okay. So experimentally value of K is observed to be equal to 1. That is the case, then what is going to be the speed of the wave, transverse wave on the string? We root of T divided by. So this is going to be the speed of the transverse wave on a stretched string. It is not a string. Stretched string meaning it should have a tension associated. Okay. So here I would like to explain one important point. If you observe, the speed of the wave in this scenario is dependent on a parameter called tension, which is actually the elastic property of the string. So tension speaks about the elasticity of the string. Similarly, if I take mu into consideration, mu is going to speak about the inertial parameter of the string. mu is mass. So whenever we talk about mass decides what? Mass is the measure of inertia, right? So what I can conclude here is P will be equal to square root of tension. What can I call it as? I can call it as the elastic factor. And what can I call the value of mu as? I'll call it as inertial factor. So an important point to be noted here is whether it is going to be a transverse wave or a longitudinal wave for that matter, the speed of the wave always depends on these two important parameters. So what you can do is T, you can write it as square root of the elastic factor for that particular scenario divided by the inertial factor for that scenario. I'm not saying this for that particular, I'm not saying it is applicable only for this case. Suppose you talk about the longitudinal wave, there also you can use it. I'll tell you how to use it at that point of time. I mean, clear to this, right? So make a note. You have to write from here. Here. Then we go to the next one. So we saw how to calculate the speed of a transverse wave. Okay. Next we will see how to calculate longitudinal. Speed of longitudinal wave, which is basically sound waves. Right. So when I have to calculate the speed of the longitudinal wave, I use the same logic. What is it? V is equal to root of elastic factor divided by the inertial factor. Am I right? Right? The speed of the longitudinal wave, when I talk about some waves, it is going to be square root of the elastic factor divided by the inertial factor. Now the question is, when sound is traveling in air medium, so air is a gaseous medium. When sound is going to travel, first point to be noted is it travels in the form of compressions and rarefactions. So it travels in the form of compressions and rarefactions. So whenever the compression and rarefaction is taking place, what are the elastic parameter of that medium which is actually supporting for this to take place? It is the bulk modulus. In a similar way, what is the inertial factor due to which the gas is able to exist in that medium? It's because of pressure. Sorry. Because of density. Right? So the inertial factor of a gaseous medium is density and the elastic factor is bulk modulus. So based on this, we are going to derive two formulas. One is called as Newton's formula and the second is called as Laplace correction. The formula which was proposed by Laplace by doing a small correction to what mistake happens with Newton. Okay, these two are very important concepts. Okay. So the first one that we are going to calculate is Newton's formula. Right? So we know that the speed of the sound is going to be square root of the elastic factor of the medium is bulk modulus divided by the inertial factor is going to be density. This is where I want you all to pay attention. So when Newton tried to derive this expression, right, he assumed that air travels in a given medium under isothermal conditions. So what did he say? That sound travels in an air medium under isothermal conditions. So it is written as bulk modulus, the subscript I. What does the I stand for? Isothermal condition. So square root of bulk modulus under isothermal divided by the density. Am I clear with this? So from this, we need to derive a particular equation where we will be able to substitute the values and find out the speed of the sound in that particular medium. Right? Let's see how to do that. So in isothermal condition, what is the under isothermal condition? What do we say? PV is equal to constant. Am I right? So when PV is equal to constant, when I start differentiating on both the sides, so what do I get? I get P into dV plus V into dP is equal to C. This we have seen in thermodynamics. PdV plus VdP is equal to 0. So which implies P will be equal to, how do I write P? It is minus dDP divided by dV minus VdP divided by dV. An important point to be noted. This is going to be minus dP divided by dV by V. So negative of applied pressure divided by the change in volume per unit volume. What is it called as? Negative of dP. dP is the stress. What stress? Hydrostatic stress. Divided by, can I say dV by V is split because it is getting compressed. So what is this parameter called as? This is what is called as bulk modulus. So this will be equal to the bulk modulus under isothermal conditions. So this is what is PI. So the bulk modulus under isothermal condition is exactly going to be equal to the pressure. So I can take these parameters and substitute it. So what I will get is, I'll get the speed of the sound in which medium? In air medium under isothermal condition is going to be equal to square root of P divided by, I mean, clear with this. So it's going to be square root of P divided by rho. Right? This is the expression which was proposed by whom? Newton. That's why it's called as Newton's formula. So two important points I want to remember. For Newton's formula, we assume that the sound travels in air medium under isothermal conditions. Second, under isothermal condition, bulk modulus is exactly equal to the pressure. Right? Numerically, it is equal to the pressure. Take that value and substitute it. Okay. So this will be the required expression. Yes, mass. Why do you need to measure? Yeah, you calculate density only, you will not take mass. You take a sample and take the volume accordingly and then calculate. You will take 1 gram and you will divide it with 1 cubic centimeter. That gives you the density. இப்போ இந்த புக்ல ஒரு சாம்பிள் எடுத்த போதுமே that is why you calculate density. Mass எடுத்தா தான் தலைவலி because mass is have to multiply with the whole area. And with respect to something like to differentiate it, you want to do it with respect to volume conservation. Up a P dV by dV plus P to 1. Your differentiating is what? P into 1 plus V into dP by dV is equal to 0. Rearranging the intensity. Both are same. Here, shall I proceed? Okay. So here, observe. So according to Newton's formula, this V is equal to root of T by root. Right? Now what we will do is under normal temperature and pressure. If you observe, right, if you see what is going to be the value of pressure in the air medium, it is going to be 1.013 into 10 power 5 Newton per meter square. Basically 1 atmospheric pressure. Right? And if you look at the density of the air medium, is going to be 1.293 kilogram per meter cube. Now what I need to do is I need to take these values and plug it into that expression. So I get P is equal to square root of P divided by root. When I do this, I'll have square root of 1.013 to 10 power 5 divided by 1.293. To calculate this value, right, this will approximately come out to be 280 meters per second. when you calculate everything, it will be approximately equal to 280 meters per second. But in reality, the point that was observed is the speed of the light, the speed of sound in air medium under NTP is actually not 280 meters per second. Rather, it is somewhere around 320 to 330 meters per second. So, if you take that value, right, practical value of 320 or 330, let's take 320 for that instead. If you take the practical value and calculate the error, then the error will come out to be somewhere around 16%, which cannot be equal. Right? The error is 16%. So, this gave a stating that the condition that was assumed by Newton was wrong. Means the sound in the air medium is not actually going to travel under isothermal condition. Rather, it will travel in the form of adiabatic condition. So that was the correction done by Laplace. So that's why we call it as Laplace correction or Laplace speed of sound in the air medium. Mostly it is called as Laplace correction. Okay, so what he told is, this is right, E is equal to square root of B divided by rho is right. This possible it is not going to change because that is a basic parameter. But make a note that it will not be isothermal condition, it will be adiabatic condition. If that is the case, then we need to start writing it as PV power gamma is equal to so you have to understand the PV power gamma is constant. Is again I have to start differentiating. So what I have to do is P into derivative of e power gamma will be gamma into b power gamma minus 1 into dv. Because I am again changing gamma into b power gamma minus 1 into dv plus b power gamma into dv, and this value will be exactly equal to 0 because derivative of constant is again 0. So what do I need to do? I need to again calculate the value of minus dp divided by dv by v, like how I did in the previous scenario. So for that, what I'll do is gamma into p, right? Gamma into p into b power gamma minus 1 into dv plus as equal to minus dp into b power gamma. Right? So p will be equal to minus dp divided by b power gamma, and you have e power gamma minus 1. So what will happen is it will become b here. The whole divided by dv will be equal to this p is there, so there is a multiplication factor gamma that is associated. So it will be gamma times p. I repeat it, listen. Gamma times p will be equal to minus dp divided by this dv has come this side. B power gamma by v power gamma minus 1. Observe. B power gamma by v power gamma minus 1. Can I write it as b power gamma by v? Are you able to understand this? So v power gamma and v power gamma will get cancelled. V will go to the numerator. That's what I wrote it here. Now what I can do is I can bring this v to the denominator so that it becomes minus dp divided by dv by v. What is this value equal to? This is the bulk modulus under the adiabatic condition, and this will be equal to gamma times p. So what is the concept here? VA will actually be gamma times p. So V will be how much? Square root of gamma times p divided by, and this was the correction that was done by Laplace, and this is the one that gives you the exact value of speed of light in that particular air medium. Okay, absolutely. So previous page why Laplace correction? Let's know what is the speed of the to calculate some problem. So we discussed mathematics and do some problem. Question number one. Equation of a transverse traveling wave is observed to be y is equal to 0.05 sine of 2 pi into 0.05x minus 10t, where x and y are in meter and t is in second. Then y are in meter and t is in second. Calculate A, the amplitude, B, the wavelength, C, time period, D, frequency, and E, speed of wave. So these are all the parameters that you need to calculate when this kind of an expression is given. Okay. It's a very, very, very simple question. Good. What will be the answer for the first one? Amplitude is. So we know that y is equal to a sine of kx minus omega. So if you do the comparative study, a0 is 0.05. So the amplitude is 0.05 meter. What about the wavelength? See, this is 2 pi by lambda. This is k, right? 2 pi multiplied with 0.05 will give you k. So k is how much? K is 2 pi into 0.05. How much will that be? 0.1 into pi. Which implies 2 pi by lambda is equal to 0.1 times pi. Okay, we have cancelled 2 pi. So lambda would 2 divided by 0.01. How much is it? Not be this less. Oh. Sound no? Correct. So it will be 200. Wavelength is going to be 200. See, basically, can I say 1 by lambda is equal to 0.05? 2 pi into this is 1 by lambda, right? So I'll rearrange it, right? And see, y is equal to a sine of k is 2 pi by lambda minus this is 2 pi by capital T into T. So if I take the 2 pi outside, y will be equal to a sine of 2 pi into x by lambda minus T divided by capital T. Correct? So 1 by lambda is equal to 0.06. So lambda is how much? 1 divided by 0.05, or it is going to be 100 divided by 5. It should be 20 meters. It is 20 meters. What about the time period? So for the time period, you can do a comparative study of this and this. 1 by capital T is equal to 10. So 1 by capital T is equal to 10, which implies T is equal to 1 by 10 seconds. Am I right? It will be 1 by 10 seconds. Similarly, they are asking the frequency. So frequency is equal to 1 by time period. Frequency is actually going to be 10 hertz. It's 10. Right? Then what is the last value? Speed of wave. So remember, speed of wave is equal to omega divided by k. Why is it so? Because omega is 2 pi f divided by k is 2 pi by lambda. 2 pi and 2 pi will get cancelled. Lambda will go to the numerator. Lambda equals this speed of the wave. So it is equal to omega divided by k. What is going to be the value of omega here? 2 pi into 10. So 2 pi into 10 divided by what is going to be the value of k? 2 pi into 0.05. 2 pi and 2 pi are gone. So how much will it be? 10 into 10 power 2 divided by 5. It goes to, so it will be 200 meters per second. They have given 20 meters. So they got the value of something else as 2 rate. That was the mistake. So it is 200 meters per second. So these are all the values. Make a note of it. there are concepts we take this reflection of waves, standing waves, and waves. Doppler effect is one there. So these three concepts are there, which I think are comfortable with. Okay. So revise all these concepts. Any other questions? Well, what all concepts did we see today? We saw almost five mathematical equations. That itself will take time to absorb. One is the speed of the wave. Second is relation between wave speed and the particle velocity. Then, so speed of the transverse wave means that we saw the speed of the longitudinal wave. Under that, you saw two concepts. What are they? One is the Newton's formula, the Laplace correction, and we did a problem. Right. So it will take some time because the next concepts are slightly heavier. As I told you, that demands more of mathematical equations. So before coming to the next class, right, revise all your trigonometric formulas. So there are two things we need to go. Trigonometric equations you have or delete it. You have no. So go through all the formulas. So trigonometric equations, those things are there. No, sin theta is equal to 0, cos theta is equal to 0. Theta is sin x is equal to 0, x is equal to n pi. You know all these things, right? Go to pass to make a note of. There are 6 formulas. So I'll tell you what are the two basic things you need to revise and come. The 4 formulas: sin c plus sin t, sin c minus sin t, cos c plus cos t, and cos c minus cos t. These 4. Fifth one is sin x is equal to 0, cos x is equal to 0, tan x is equal to 0. Sin x is equal to sin alpha. Sorry, sin x is equal to sin y, cos x is equal to cos y, and tan x is equal to tan y. So tan also you can leave, sin and cos both. Okay. So those are needed for you to understand the next part of it. Okay. So any more doubts? That's it. Okay, then we'll wind up.
Thank you, sir.